is that we have what? Tuesday, Wednesday, Thursday, Friday, then we have a full week,
I won't be there.
and then it's finals.
Wow.
What I'm looking at here is, between these days and up in here, we're gonna do matrices.
Matrix?
You learn those in?
I showed you guys how to use a matrix, but I didn't show you guys what they're actually doing. And in talking last Wednesday with the pre-calc teachers about some of the things that they wanted you guys to be able to do or understand a little bit of why it works beginning of the school year is some matrixy stuff. And in the past, we've done that chapter, but this year we cut it out. So we're gonna put it back in. It seriously is like 4 sections, 5 sections tops. It does not take more than 4 or 5 days. It's not. It's weird. It's a lot of stuff that you're gonna, I mean, there's buttons on your calculator to do all of it, but you know me. You won't be using them.
I know you.
So what we'll probably wind up doing it is, usually with the matrix stuff, I have like in the past I've done like a 4 or 5 little question quiz at the end of it that's all non-calculator. That's probably what I'll just wind up doing. Then we'll probably look at it maybe like that following Tuesday-ish. That'll give us a good solid 3 days of some extra work to study up on for the final. As far as packets or anything like that, I haven't gotten anything put together yet. I'm starting to piecemeal some stuff together from what I had last year, but then we added in new stuff, so I'm gonna find other stuff and put it all together. Hopefully I will have that probably by the end of next week and go from there. Remember, the finals are only 20% of your grade. They very rarely help you. They can hurt you, but it's usually plus or minus % or 2 is really all it's gonna do. When you have a borderline grade, it's easy. It's so much easier to stay where you are than it is to move up. Unfortunately.
I'm trying to stay where I am.
Well, think of, and we'll worry about all that kind of junk later. But let's talk about normal distribution.
Well, we haven't tested on the matrices.
He just said,
But
that.
it's
Just said, all right? He said we have 4 or 5 question quiz, no calculators, because that's, you know him, right?
I don't know. I don't know how he said he wasn't going to let us use calculators.
No, he's right. That's what I said.
You know him.
Normal curves. Normal distributions. Some of the things, we've talked a little bit about this before. When you look through binomial distributions, remember how it was a whole bunch of bar graphs?
Oh, like a history? Looks like a history.
Something like that, a histogram. A normal curve is just following the values and does that, okay? A normal curve is a smoothed out version of a bar chart. Woohoo! So what happens is,
Kind of sounds like a line.
you wind up with a curve that looks like that. A normal curve has its peak at the average value. And I'll do an example here in a second about where these things come from. Underneath that whole curve is always going to be 100% of all data. So I know half of it is on one side, the other half is on the other side. Yeah. So we have normal distributions. So we'll have normal distribution and paranormal distribution.
Paranormal.
Should we draw that?
Should we draw that?
Yeah, so we got those on the other.
Anyway, so normal distributions come from working around averages. Do not worry about drawing out histograms and making any of these curves here. What I want you guys to take from this is that an average, think of the average height of a male. Average male height. We looked this up last hour.
6'2", 5'11", 5'10", 9'11".
Wait, and a man on the left.
That's what's wrong.
Can I just talk and finish, please? An average height of a male is 70 inches. That means the most, when you look at a curve, There's 70 inches.
Oh, it's like a learning curves? Or how they like protest, how they
Mhm. If something is set to be normed, if distribution is normed, that means that an average, they call the mean, I'm sure you've heard that before, right?
Yes.
pretty.
They usually put it with an X with a bar over it, right? And then they'll say that data is within standard deviations, an SD sometimes. And that's given by, I think this is B. It's like a lowercase. What they'll say is that a standard deviation is a relationship to the average. It's a way of measuring how far you are from an average. If the data is normed, these cool things happen. Within plus or minus 1 standard deviation, 68% of all data occurs. Okay? 68% of all data. What's that? 68% of all data is within 1 standard deviation. So if it's 1 standard deviation on both sides, if this distance is going to be 68%, how much is on each part? 34. So we know that 0.34 is here, and 0.34 is here. Well, we looked this up last hour, and we said that 1 standard deviation on this set was 4 inches is a standard deviation. So that means between the heights of 66 inches and 74 inches, 5'6" and 6'2", 68% of all males fall into that category.
It's cool.
Mm-hmm.
Wait, can you like just find out the number 66 and 74 how we can help them?
It tells you the standard deviation is 4. It'll tell you the standard deviation is 4. So that means these charts they're always going to be built like this. All right.
They'll always tell you that.
I might can make you find it. It's not that tough.
Yeah, that's what I'm saying.
We'll worry about all that tomorrow. I'm just going to get into the basics of this now. So now if I go out to 2 standard deviations, going both ways, the next height would be 78, and this one would be 62. Now, within 2 standard deviations, 95% of all data occurs within 2 standard deviations. So if you think about it, 95% of all males are between the heights of 5'2" and 6'6". Okay? 95% of all males would be in between those heights. That's what that means.
It's like exactly 95 or 95.
No. So now what I want you to see then is between here and here is 95%. If I take out the middle 68, how much percentage is left?
13.5 each.
Yeah, you get 13.5 on both of those little charts. So in here there's 0.135, here there's 0.135. Remember, the total area underneath the curve is going to be 1. What's that? What happens is, we know within 2 standard deviations is 95. I subtracted out the 0.68. And then I took that and cut it in half. Okay. This is how this is always going to work. And then 3 standard deviations is 99.7%. 3 standard deviations. And that leaves you 0.3% on both tails who are called outliers.
Outliers.
That guy that's 7'6", or the person that 2'3", around those lines. Okay. Yes, ma'am.
I saw a picture where like the largest documented person on Earth met the smallest documented person on Earth. It was really beautiful. I'll tell you that. Funny story, I guess.
82.
Was this recent?
Yeah, I think I know what you're talking about. So within 3 standard deviations is going to be 99.7% of all data, which means on these little outliers, there's that 0.3% left. So over in this outlier would be 0.015, here would be 0.015 on the tail. And then to figure out what's left in the middle, take 99.7, subtract the 95, divide it 2 years. So in these two spots, there's what, 0.0235?
Yeah, because together it would be.
So what happens then is that all data, if it's normed, all data would fit underneath the curve. So yes,
Will there be a curve where it's irregular inside?
and that just means it's skewed. Skewed data can be normed, and that's what a lot of things. That's what they do a lot of in statistics is that you can take different data. You can take different data sets and stuff like that, and you can do math to them, and then they norm it.
Sounds good.
So it can be done. It's not something we're going to worry about. Because the stuff I'm going to tell you is that it'll be, hey, this is normal. Okay. When you get into some of the statistics things, there are things you can do with what are called z-scores and things like that, where you can do things where you can normal. So what we're going to be able to do is, just for today, to start with, we're just going to start looking at just number sets and looking at values and how they relate to one another. I'm not going to get too crazy with a lot of this to start.
So what are we supposed to be able to do with this?
I'm going to show you. You can answer these types of questions. Yeah, Moose says that a lot. What the what?
Really?
So here it says the survey shows that time spent by shoppers in a supermarket is normally distributed, with a mean of 45 minutes and standard deviation of 12.
That's how you spell the deviation.
That's why I know it.
I influenced.
So it's like the.
So if this is 45, that's your average. When it talks about one standard deviation is 12, well, what's the next one going to the right? 57. Going to the left, it would be subtract 12 again, you're at 21. Subtract 12 again, you're at 9. Add 12, you're at 69. Add 12.
81.
So you can mark out a very easy bell curve. You've heard that, right?
Yes.
These are your bell curves. So what percentage of shoppers are at the supermarket will spend between 33 and 57 minutes?
Let's see.
68%.
Oh, that's the same for averages?
Yep, and that's the whole point.
That's what I'm saying. I didn't know if you were.
And that's the whole idea. When you have data that's normed, for normed data, that should be my nickname, normed data, this always happens. Normed data, and that's why they look at it as when you're normed, you can follow these rules. So between 33 and 57 minutes, 68% of people are in the shopping, whatever, supermarket. If I'm in the supermarket for 81 minutes,
Right. A lot.
I mean, unless they have a lot of samples.
Costco.
And then it asks the next question. What is the probability that the randomly chosen shopper will spend between 45 and 69 minutes?
So can't you just add those?
That's all you do.
So.
So what happened? And it goes back to knowing the curve. Between here and here is how much percent?
30.
And between here and here is how much percent?
35.
So what's the probability that you land in there?
Yeah.
There's your answer.
Are we gonna have to memorize those numbers, like the 68, 95, 99?
If you know these, you can build anything. Because it's just a matter, bless you, it's just a matter of knowing how to subtract and divide by 2. I ask a lot, I know. I have these high expectations.
Try.
Good luck.
Make flashcards.
Oh, because
You
I
know
had
you-
it was 34, sorry.
She might be playing with flashcards.
I thought I was the one that got hit in the head this weekend.
Sick burn.
I was gonna say.
I probably did, I don't remember.
Oh, this hurts.
Shout out to Gabe.
According to a survey at the National Center for Health Statistics, because there is such a place, adult men in the United States are normally distributed with a mean of 69 inches and a standard deviation of 2.75. Now, this data was different from what we Googled third hour. We literally just Googled what the average height was per male and just used that.
I mean, it's not off by that much, but the
No.
deviation's off.
Deviation's off. Yeah, so I thought that deviation seemed rather high. But this one doesn't seem, this one's, you know what, this one seems rather low. So if you mark this out,
Why don't we go into?
Well, this is in the United States. So Cullen's not been in the world.
Maybe those English are.
Nice.
Yeah, even though probably should.
Because that would make sense for why it's such a high deviation, because it's such a wider spectrum.
it's true. Who knows? I don't know what you Googled. Somebody call him and ask him.
Yeah, the yellow is probably below the bottom.
Why not Google?
Then we got the question.
So we know that your standard deviation is 2.75. So this is one next spot is 71.75. So if you think about it, on this side of the graph is how much?
On that side.
That whole left side is 50%. Do I need to mark any of it out? No. I know this is 0.34. Now, going over here, it's asking you, what's the probability that you're going to choose 3 men that are going to be taller than 71 centimeters, taller than almost 6 foot? Now, the probability here is, if I'm going that way, how much is left over?
You have 0.16, so you have to.
Yeah.
0.16 times.
I'm asking a different question right now. I just want to make sure you guys are understanding. We know from one standard deviation, everything going over this way is 0.88. So going this way is how much?
0.8.
No, not 0.8.
How much is left? 0.12.
No, it's
Simple math.
0.84.
Where you go?
No, math is hard.
It is. We know you.
I got hit in the head. Okay? So the probability of one person to be taller than, excuse me, is 0.16. How do I do this? Cube it, just do it 3 times.
You have less than a 1% chance.
Do you see how this is just using this distribution chart? And you have to know these. If you know these, everything's fine. And how it lays out. It is extremely simple to work with norm data.
Armin Bates.
Questions? I'm just gonna give you a couple of these to start with.
Wait, this is the last section?
No.
No, because I got a couple little things. We're gonna finish up a little bit more of this tomorrow. I just don't want to go too far into it today.
Excuse me.
I wish I had that too.
What?
This is 12/7.
Yeah.
I thought it was He's so laughing so bad.
What are you talking about?
I have no idea what it was.
So this is 12.5 or 12.7.
So 23 through 31.
I feel bad for whoever it was. I don't think it was him. It sounds like maybe it was a while ago. I told you that.
No.
Wait, page 715, 23, like maybe it's
Yeah.
a girl.
What's that?
Like I came over there and saw you.
I got hit in the head. I can't remember anything.
Do you remember which chapter section we had to read the last chapter?
Wait, all of them? Wait, Hannah, you have a homework assignment that this takes so just 20 days. Or 20 days.
Yeah, let's do those.